In this second video, we're going to also use the image sampler, but instead of creating it as a series of pixels or circles, we're going to create a series of fins that make up the image as a whole. Now, the first thing I'm going to do is drop my resolution because resolution of 4 dpi is quite high. We don't quite need it that high. Plus, let's keep it lower early on while we're working on our definition. It'll create fewer number of control points, and they'll actually let the definition work faster because we went from having 40,000 circles to now only having about 2,600 circles. So it'll help operate quite a bit quicker. Now, we're using the base file that we started with the last definition. If you don't already have this, including this new expression, you may want to go watch the previous video, the image sampler step 00, as a precursor to this to get you up to this point. You also may want to make sure that you save this file as a new file so that you have the original image sampler step 00, and now we're working on image sampler step 01 to create a series of fins for this image. I'm also going to change my view now to a perspective view. And in doing so, what I'm going to do is be able to kind of see it three-dimensionally instead. Last thing I want to do is we're no longer going to make circles out of this. What we're going to do is we're going to create a series of fins, first in the vertical direction, and then in the horizontal direction that are standing up on end and along the z-axis. Okay. To do that, we don't need the circle CNR anymore. And in fact, we can change this this expression here because this is no longer actually even controlling circle radiuses, therefore we don't need the expression. So I'm going to delete that out of there. And what we're going to do is simply take the grid points. Let me go turn that grid point back on. And you can't see the points necessarily in this component. Sometimes if I like to see the points, I'll go to Parameters, Geometry, and you put a point container in and just run the points into that. You'll see they show up as X's. And I can turn the grid back off and just see the original X's right there. And that might just be a visual. You don't necessarily have to run it through there. It just helps visualize or see those X's, those points a little bit easier. What we're going to do is we're going to move those points vertically in space. We're going to connect a series of vertical lines from the original point to the moved point, and we're going to loft all those lines together along each column. So here are our points. We're going to use a simple move component. So let's go to Transform, Euclidean, and Move. And remember, there are two different things you need for a move component: a geometry to move, that's easy, those are the points. And you also need a translation vector, and by default that's 0, 0, 10, meaning 0 it's not moving any in the x, not moving any in the y, but it's moving 10 positive units in the z-axis. And you'll see we get a second grid of points that are floating here in space. We want to use this image sampler, and in particular this remapped value. Now we actually don't even need to use the remap, but we'll just use it as is. We'll see if we like it, and we can modify this if we are not happy with that. So what we're going to do is we need a translation vector. Now a vector is comprised of two different things. It's a magnitude and a direction. The direction's easy. It's going to be the z-axis, upward basically. Okay, and the magnitude is going to be the grayscale value or the remapped versions of these grayscale values. So to create the z-axis vector, let's go to Vector tab, Vector panel, and a unit z. This defines the direction as in the z direction, but it then requires a force, and by default a force of 1 unit is stored in there. We want to use the remapped to control the force, so that'll become the remapped values of the grayscale. The 0 to 1 numbers become the force, and we'll use those z units as a transformation. Now you should even start to see, if you kind of look at it in the right angle, a little bit of your image popping through, and you might even help a little bit if you turn off the original grid of points. You can kind of see it like so. Now what I want to do is I want to make a series of vertical lines. I want to turn on my original grid of points again. I want to create a series of vertical lines from the original grid point to the newly moved point. So to create a line, just go to Curve, Primitive, and Line. And it doesn't matter what you put in A, what you put in the B, but make sure the original grid is into one of the inputs and the moved grid is into the second set of inputs. And I'm going to turn off some of this old information. There we go. And now we get a series of these vertical lines, which in and of itself is kind of interesting. Again, you can start to see a little bit darker where the lines are longer and a little bit lighter where the lines are shorter. Taking those lines and we can loft them together. Now the important thing to think about or to understand is you have these dashed wires. Remember, dashed wires mean that there are multiple lists within that string of data. We're going to run that into a panel tool just to understand it. You see you get a whole lot of line-like curves, And at some point after the 51st line, we get a split in the second line. Remember that this is being organized by columns. So there are 50 line-like curves, or excuse me, 51 line-like curves in the first column. Then it starts over and another 51 in the second column, so forth and so forth. If we loft these together, remember all Grasshopper operations work within a single list. It will only loft together these first list items, then it'll loft together the second list items, third list, so on and so on. To do that, go to Surface, go to Freeform. We're going to go ahead and go to Loft. We're going to run those curves simply into the loft, turn them off. And now you'll start to see that we get a surfaces out of those objects. Okay. Now those surfaces are standing vertically and they're running along the y-axis. We use the remapped values so that the darker areas are larger, meaning that they have longer offsets. If we were not to use this remap value and just take the actual values, again, that image would look inverted because the white surfaces would be longer and the darker surfaces would be shorter. So we're glad we did that so that the image does not look inverted. We want to use those remapped values, so I'm going to wire that back in. There we go. Now, I'm going to delete this panel out of here. Start to organize this a little. We got all of our points, our lines, and our loft like so. Go ahead and group that. And there, that's all about making the surface. Now, what if I wanted these to go horizontal opposed to vertical? What if I wanted the fins to run along the x-axis opposed to along the y-axis? To do that, we have to rework how Grasshopper organizes the data. Remember that the data is organized after the square grid component by column. If I want to swap it and organize it by row, that's easy. We use a component that's called flip matrix. So if you go underneath our sets, go to tree, and you can go to flip matrix. And you'll see here it flips a matrix-like data tree by swapping rows and columns. We want to go ahead and drop that in. And we want to do that as soon as we've created the square grid, or right shortly thereafter, before we use any of that data. So you'll see now what it's going to do is swap the items in the rows for the columns. So instead, this first point, let me go ahead and turn on these points. It's actually, remember, it's easier to see if we turn on the point component, like so, and I'm going to turn off the vertical fins. There we go. So remember, this first row is the first list. This is the 0 index item in that row, 1 index item, 2 index, so on and so on. And the second list, this is the 0 index, 1 index, 2 index. What it's going to do is it's going to connect all the things that have the same index number. So all the 0 index numbers are now going to be put into a new list. And the first row item is going to be 0, now 1, then 2, then 3. Then the second, the index number 1s are all in a list. Index number 2s will all be in a list, so on and so on. That's what swap or flip list does. So let's go ahead and run the points into there. And now anywhere where these were going, we're going to replace them. So basically, they were going into the image sampler. We're going to replace it there. And it was going into this point component here, so we're going to replace it there. Now if I go ahead, I'm going to bring this down and right-click, add it to this group. And if I go ahead and turn these back on, now you'll see what's happened is that these fins have moved from being organized in the columns to being organized by the rows. So we've gone ahead and flipped those. Now what if we wanted to lay these down, make them on the XY plane? That's simple. Instead of moving along the Z-axis, this scenario we want to move them along the Y-axis, because again we want to lay them down so that the length of the fin runs along the X and the width of the fin, if you will, runs along the Y-axis. So we want to move the points from their original grid locations, which are right here, along the y-axis. So we're going to swap out this z unit for a y unit. So go to Vector, the Vector tab, and y unit. Wherever that's coming from, we're going to wire it in, like so, and use this as our translation vector. There we go. So now what it did was it laid it all down. Turn off my points for a moment. And now it's gone ahead and created a surface that's laid down on the XY plane, but runs along the x-axis of fins. Again, if I want them to run along the y, I have two things I have to change. First thing I have to change is no longer flip the matrix. I want the columns to be organized. I don't want to use the flipped matrix. So I'm going to go ahead and rewire this. I'm going to wire it also into this other location like so. And I also have to change now, because I want the fins to be laid down along the x-axis, change this F unit to a x unit. So again, the remap values are going there, and now we're going to use this one instead. And now they got moved, pushed along the x-axis like so. Okay. So depending on the combination of how the objects are oriented, in which direction you want the fins to be laid out or laid down on, which plane you want them on, you can go ahead and make the image several different ways, swapping using this flip matrix to swap whether you use the XY, the YZ, or the XZ plane within there.